Hey everyone, this is Mayur. Welcome to ML Works. In this video, we'll talk about Dask, a parallel computing library that helps Python to share the workloads across multiple CPUs or multiple cores. When I say multiple cores, it is on the single machine. You can utilize the cores efficiently, or you can also distribute your task across multiple machines on a cluster. Okay, so basically, what it does is its purpose is to what perform either to dynamically task schedule the task, like how does Airflow works, or you can also perform something called as big data processing. For instance, if you have a huge data set and you don't have a memory to what compute the whole process the data on whole. Okay, you turn that into chunks of data and process it and quickly get the result. So that's what big data processing mean here. So what we'll do in this video is we'll just look at this library in a short video of just another 5 minutes, and we'll understand basics here. Okay. So first what we do is we install Dask using pip Dask complete, and then we have basic packages NumPy and pandas getting loaded, imported, and then we take in Dask data frame. So once we import that, next, what we do is we create a index of data. Data means date from date range for the 3 months or a period of 1 hour over a period of 2400 hours. Okay, which is around 3 months. So next, what we do is we create a data frame and where we have two columns A and B, and column A takes in a range from 0 to 2400 and B a list of a string which is spanning across 300 times. So that is around what 1000 this as well. Okay. Next, what we do is we turn this pandas data frame into a Dask data frame using from pandas using this function. Now, once that is done, we'll look at Dask data frame how it looks like. So if we look at this particular data frame structure from Dask, we can see that this data frame from pandas is a 2400 records around, because we have like 2400 period with the 1 hour period. Okay, so we have 2400 records and we partitioned into 10 partitions. So one partition will contain about 240 records. So we can look at the divisions. So we can look into the divisions. There are like timestamp for one division from 1 to 1. Okay, so there are totally around over the span of 3 months we'll have this divisions happening of 240 hours. Now we can look into each partitions. For instance, this is 3, so this is 0 partition, 1, 2, 3. Okay, so this is partition 3, and what we can do is we can process this based on our requirement. We can process one after another. If you don't have memory efficient enough to handle all the partition together, we can do it one by one and pre-process the data. And one thing, if you notice, what we have given here is a range. Okay, NP a range which is a value of 0 to 23,999. Okay, and it is a string characters A, B, C, D, something like that in a list format. But what we do see here is when we try to check in a Dask data frame, we see only the data type of that particular object. Okay, the particular data type of that particular value. We don't see the value itself, we just see the data type here. So what happens is Dask, it doesn't compute these values. Okay, it is not generating those values in runtime. Okay, for when you, because unless you are not using it, you don't need it. Okay, so it's not currently occupying that memory also. So what happens is by this time, okay, if you run, okay, DF has already created these things. Okay, these values are already stored. Okay, but when you are handling in Dask data frame, it has not created that value. Okay, it is still there as a in the backend. Unless you do something called as .compute, it will generate those values. Okay, so that's how it works. It's something called as lazy evaluation. Unless you don't need it, it doesn't create it. But once you do .compute, it will start creating those values. For instance, what I mean is, so this is one method to how we do filtering of records based on index. So this is also one way to do that. And here, if you look at, when we filtering, we are seeing these values in the data type int64 and the object. So when you do compute, okay, we'll see a different value coming up here, because what has happened is it started computing the values for that particular column. Now, similar to pandas and numpy, we can do what straightforward mathematical operations on Dask data frame using existing keywords like mean, max, all other mathematical functions. Yeah. So even here, if you do just mean, it creates a series. Okay, but it doesn't compute the value. For that, you have to specially give dot compute, and it will create that. Now this is a Dask data frame, and if you look at this one, this is a data frame from pandas, and we'll look at this thing. So if we see here, it also generates the same value. Only thing is, small things that I noticed here is the time taken. Here it is 3.58 microseconds. This is 5.25. This is pandas data frame. This is Dask data frame. Now let's similarly we compute max. Then we compute memory usage. Okay, memory usage is nothing but what is the memory occupied by the Dask data frame. So that is something we can look at using memory usage module. And then what we have is we create a series of operations that is happening here. Okay, here what we do is Dask data frame, we are trying to filter it, and then we are selecting a specific column, and then we are doing something called as cumulative sum on that column, and then we are subtracting -100. So that will be stored in a result variable. So we can see that sequence of operation that is happening using results.dask. This is the high level graph that is getting generated for this one series of operations. So layer 1 from pandas, yeah, that is we are getting that from pandas, and then locating the items, then performing cumulative sum, and then subtraction is taking place. So these are some of those what basics of Dask, right? How it happens, and how it similars to what other libraries like pandas and numpy. So this is just a basic video what we are trying to do in this particular session. Okay, what we'll do is going forward, I'll be doing some high computation comparison between pandas and Dask, such that we can understand this better. Thank you till then.